Hello, we are on 2.02. Gotta use the pen here. 2.02 PreCalc notes today. And we're talking about polynomial functions. So we'll talk a little bit about how to figure out what a polynomial will look like without the use of your calculator. So looking at the equation and what we can tell from the equation just by looking at some of the characteristics of it. So the first thing we're going to talk about is the lead coefficient test. And the lead coefficient test really just looks at your lead coefficient. So if you have an equation or a polynomial here, f of x equals a sub n times x to the n plus something, plus then we'd have our last couple terms here. What I want you to focus on is this lead coefficient right here. So the first term, and the coefficient of that is a sub n. So we want to know if that is positive, and we also want to know if the n, so really your exponent, is even or odd. So we're going to make a little chart here. If a sub n is greater than 0, we're going to have if a sub n is less than 0, so that's going to be if it's negative. If it's less than 0, here is if the first term is positive. And then on the left side over here, n is odd, and then n is even, so the exponent. So that's talking about the lead exponent. So that would be the highest exponent if it's the lead one, is your n. And then a sub n is your coefficient. So is the first term positive or is it negative? Is the exponent even or is the exponent odd? So let's say in this first box, a sub n is greater than 0, so the first term is positive and n is odd. Then you would have a graph that it tells you two things. So first, if n is odd, it tells you it's going to be going in opposite directions. So if it starts from the coming up, rising from the bottom, then it's going to go up to the top at the end. So they're going, one's going up one end of the graph and the other end of the graph is going down. It means opposite, odd, opposite, odd, opposite. And then if n is even, that tells us that they're going in the same direction. So they're either both going up to the left and the right of the graph, or they're both going down. The positive tells you what's going to happen at the end of the graph. So the positive tells us it's going to end going up, and negative tells us it's going to end by going down as the final behavior. So for example, your lead coefficient for this first one could be 2x to the 5th. So the 5 is odd, that's the exponent is odd, and the first number 2 is a positive 2. So if that's the case, then we know it's odd opposite, and it's going to end by going up. So I know it's going to end by going up. Something's happening in the middle, I don't know what, and the other side will be going down. So they're going in opposite directions at the beginning and the end. So we'd say here it falls to the left and rises to the right. Okay, and next we'll look at if we have a negative in the front. So for example, negative 2x to the 5th might be our lead coefficient here. So the first number would be negative and the highest exponent would be odd because it's 5. So still odd opposite, odd opposite. So, but instead of at the end going up like we did on the last one, we're going to end by going down. And again, something happens in the middle. We don't know what. And it to the left, it would be going up. So it would start by rising. So rise to the left rising going towards the left and falls going to the right. The next one we have is if a sub n is positive, and let me just put my grids on here now. A sub n is positive and n is even. So you might have something like 2x to the 6th instead. So it's still a positive 2 in the front, but this time your exponent is going to be even. So it's a 6. In that case, we know they're going to end by going up because it's positive, but we know they should be going in the same direction. So it's also going to start by going up. And again, something's happening in the middle. It might not be that many curves, but something along those lines. Okay. To describe this in words, we'd say it rises left and right. And then the last one, we want a negative coefficient, so negative 2, x to the, and again, even exponent, so x to the 6th. So this one's going to end by going down since it's negative, but since it's an even exponent, they both do the same, so they're both going down. So we'd say in words here that it falls left and to the right. So by looking just at that first term, we're able to tell a lot about what the graph is going to look like at least at the end behavior, we call that. So going towards the left or to the right. So for the next one, I want you to use the lead coefficient test, I'm going to call it LCT, to describe the end behavior. The left and right hand behavior, also called the end behavior. Okay, so letter A is f of x equals negative x to the third plus 4x. So again, we're focusing right here on our highest exponent, our lead term. First, we notice it's negative because it's a negative 1 in front of the x as our coefficient, and the exponent is odd. So that tells us two things. It tells us that it's going to odd opposite, so one's going to be up and one end is going to be going down, and since it's negative, the end all the way to the right is the one that's going to be going down, which means the left should be going up. So we'd say here rises left, falls right. Letter B, f of x equals x to the fourth minus 5x squared plus 4. Again, we're looking at that first term. So we have a positive 1, so it's positive, and an even exponent, the exponent is 4. When it's even, they're going in the same direction to the left and to the right, and since it's positive, we know it ends by going up, so that means it's going to start going up as well. Something happens in the middle we don't know, so it should look something like that, telling us it rises left and to the right. And lastly, letter C, f of x equals x to the fifth minus x. Pause the video here and try to figure this one out on your own. And you should have gotten for that one that it falls left and rises to the right. So that is your lead coefficient test. Next, I want you to find all the real zeros of f of x equals x plus 1, that quantity is raised to the third power, and sketch the graph as well. So first of all, looking at this, I know that my graph would be, my parent function is y equals x to the third, and this would be shifted left 1, because 1 plus 1's inside the parentheses, it would move opposite of what I think, so it goes to the left. Whenever I'm looking for zeros, I know that I'm trying to find where it hits the x-axis. So I want to know where y is equal to 0. So I'm going to take 0 and put in for my y, which this is an f of x instead of a y. So I set this whole thing equal to 0, like that. Now, since I want to solve for x, I'm going to write this out as 3 separate binomials. And now, since I'm solving, I'm just going to draw my line and set each of them equal to 0. And it's all the same equation, so we're going to get -1 3 different times. So our final answer here is x equals -1, and we say that we have a multiplicity of 3. So what that means is we have -1 is our 0, and it occurs 3 times. It's repeated 3 times. On our graph, we know that we are shifting our parent function, which normally goes through 0, 0. So we're going to move it to the left, -1. And we know our shape of our cubic function, y equals x to the third. So notice here when you have a multiplicity of 3, and we're going to be talking about this as we continue on, but it's an odd multiplicity, is something you want to take note of. And it cuts through at that point. So you can't tell by looking at the graph that there's more than one -1 there. But if I know the multiplicity is 3, I know that it's going to cut through that graph because it's odd. Let's do another one. Find all real zeros of f of x equals -2x to the fourth plus 2x squared. Again, when we're looking for zeros, we're looking for where y is equal to 0. So I'm going to put 0 in for my f of x. And then looking to simplify this. So I wondered if I have a GCF, and it looks like I do. I can take out a -2 because I have both 2's, and then I can also take out x squared from both of these. So if I divide each of these by -2x squared, I'd be left with x squared minus 1. And I can factor x squared minus 1 further because that's a difference of 2 perfect squares. So I can factor it into x minus 1 and x plus 1. Now we can't factor any further, so we draw our line, set each factor equal to 0, and solve for x. So we get x squared equals 0. 0 divided by -2 is 0. Take the square root of both sides. So technically you have a plus or minus here, but with zeros, they don't have a sign, so we would just say 0. X equals +1, x equals -1. So the only one that's going to have a different multiplicity would be this 0 here, because technically we had plus or minus 0. So we would say that 0 had a multiplicity of 2, because it's at the +0 and the -0. The -1 and the +1 put this. It doesn't matter. I was going to put them in order, but we'll just leave the 0 there. So -1, 0, 1, if you wanted to put them in ascending order. Here we have a multiplicity of 2 at the 0, and then at the 1 and the -1, we have a multiplicity of 1. They just occurred one time. So if we want to graph this, you would have a point where it hits at -1. You'd have a point where it hits the x-axis at +1, and then also at 0. And then what you could do at this point, before we talk more about how to do this without your calculator, is you could go to your calculator and get just an idea of what this is going to look like. So type in -2x raised to the 4th power plus 2x squared. And you can get a pretty good idea here of what it's going to look like. So if I connect my points, it looks like it's going to go something like that, almost like a little M-shaped curve. And it's going to hit at these 3 points. Notice, though, at the 0, where it has a multiplicity of 2, an even multiplicity, it doesn't actually cross through the graph, or through the x-axis. It's tangent to the x-axis. So it hits at 0 and kind of bounces off. But at -1 and 1, where you have an odd multiplicity of 1, it's going to cut through the x-axis right there. Another good thing to notice here is you should always make sure that your number of zeros is equal to the highest exponent. So in that last one, we have 2 zeros, a 1, 1, and 1, -1. That's a total of 4 zeros, and our highest exponent is a 4 in the original problem. So we have 4 zeros matches the highest exponent. So you can use that to help you when you're figuring out your multiplicities as well. So let's just write out the details of this multiplicity thing here. So multiplicity in a function occurs when a function has repeated zeros. So when we have like that 0 is repeated, or when we had the cubic that was shifted to the left one that had repeated zeros. If you have an even multiplicity, that tells you that the graph is going to touch at that point. So it'll touch the x-axis. It will not cross through it. So it'll be tangent. It won't cross. To help you remember that, I always like to think of y equals x squared, because that has an even exponent. So easy to remember here, y equals x squared. We all know what that looks like. And here at where your 0 would be, it's going to be an even multiplicity at 0, so it'll be tangent to the curve. For an odd multiplicity, it's going to cross through. So the graph will cross the x-axis. For that one, think about y equals x to the third. So you have an odd exponent. It's x to the third. So when you cross through at 0, 0 again, it'll be an odd multiplicity of 3. So it will cross through. So these are just little hints to help you remember even and odd multiplicity and what happens at them. All right, next up, we're going to move on to something a little bit different, finding a polynomial equation. So I want to find a polynomial with the following information. So I'm going to have a 0 at 0 that has a multiplicity of 2. I want another 0 at -5 that has a multiplicity of 3. And I want it to have a degree of 5, which is just be your highest exponent. Okay, and we can see here if we have a multiplicity of 3 and a multiplicity of 2, that would give us a degree of 5. So it's just kind of, this part isn't really going to help you figure this out. So we're going to do f of x equals. So if I have a 0 at 0, that's my 0. I want to know what my factor would be. So think about when you actually factor something. So if you factor x minus 3, x plus 2, and you solve that, your zeros would be +3 and -2. So I'm going the opposite direction. If I'm given the 0, I want to be able to find my factor, so I switch the sign. So I would do x minus 0. If I were to solve that, set it equal to 0, I would get x equals 0. And I want that to have a multiplicity of 2, so I'm going to raise it to the second power. Then I want another 0 at -5. So if I want the 0 to be -5, what would the factor have to be? The factor would have to have the opposite sign of x plus 5, and we want a multiplicity of 3, so that would be raised to the third power. So that is the hardest part, I'd say. The rest is long, but a little more tedious. So we're going to now just simplify this down and FOIL it all out so we get a nice polynomial. So this x minus 0 is just x, so that'd be x squared, and then I'm going to write out x plus 5 3 times because it's raised to the third power. Now I'm just going to FOIL everything out. So I can only FOIL 2 at a time. So I'm going to bring down my x squared and FOIL these. So I'd get x squared plus 5x plus 5x, so that's 10x, plus 25 multiplied by x plus 5. Then I'm going to multiply these two together. So I'm going to bring the x squared down. X squared times x is x to the third plus 5x squared. Then do the 10x. So plus 10x squared plus 50x. And then do the last, the 25. So 25x plus 25 times 5 would give us 125. Okay, so now you want to combine your like terms here. I've got 5x squared and 10x squared. That's it for my squareds. I've got 50x and 25x. So now I have x to the third plus 50x squared. Oh, sorry, 15. Add them, don't multiply them. 15x squared plus 75x plus 125. Okay, and now we want to distribute in this x squared to everything. And remember, when you are multiplying, you keep the base and you add the exponent. So 3 plus 2 would give me 5. Then I'd have 15x to the fourth plus 75x to the third plus 125x to the second. And now there's nothing we can combine. There's no like terms. So that would be my final equation, my final polynomial for that one. Okay. And the last one we're going to do is another one where you're finding the polynomial equation. So find the polynomial equation with zeros at 3, 2 plus rad 11, and 2 minus rad 11. So the 3 is fine. That's the same thing that we were doing before. These two are a little bit different. So when you have radicals or imaginary roots, I would recommend using your sum and product formulas to do that. So use sum and product with radical or imaginary zeros. So this one, the 3, is going to stay the same. I'm going to just focus on finding a trinomial that will represent 2 plus rad 11 and 2 minus rad 11 as our zeros. Now, you can do it and go straight just like you would with the 3 and do x minus 2, but you'd have to negate both signs. So x minus 2 minus rad 11, and the other one would be x minus 2, and then change this negative to a plus rad 11. And then you'd have to FOIL that out. So I think it's a little too tedious to FOIL that and more likely to make a mistake. And most students who do that often do make mistakes. So the sum and the product is a little bit safer route to go. So you have to remember, though, your formulas for this one. So the sum is our samba. That's negative b over a. So we're going to first take the sum of those two roots. So I'm only focusing on the two that have the radicals. I combine them. The rad 11s cancel. I get 4. So I'm going to set 4 over 1 equal to negative b over a. Next, I'm going to find my product of the two roots. The product formula is producta C over A. We're going to do 2 plus rad 11 times 2 minus rad 11, and this can also be checked in your calculator. 2 times 2 is 4, minus 2 rad 11 plus 2 rad 11. Those will cancel out, minus 11. And 4 minus 11 gives us negative 7. So now I'll set negative 7 over 1 equal to C over A. Make sure your A's are the same. They're both a 1. And so now you're just lining them up. So A is 1, negative B is equal to 4, so B is equal to negative 4, and C equals negative 7. So now I can write those as a trinomial of 1x squared minus 4x minus 7, and multiply that by my x minus 3, which is coming from this 0 up there. And that would equal f of x or g of x or whatever you want to call it. So now I just need to FOIL all this out together. So I'm going to distribute. So I get x to the third minus 4x squared minus 7x. Then distribute the negative 3, negative 3x squared plus 12x plus 21. Combine my like terms. And we've got x is the same, so I get f of x equals x to the third minus 7x squared plus 5x. Negative 7x plus 12x would give us 5x plus 21. And no more like terms we can combine, so that would be your polynomial function that would give you the roots of 3, 2, plus or minus rad 11. All right, and that is it for us today. And if you have any questions, please let me know. Pie out.